Hello everyone, welcome back to my YouTube channel. I'm Rishi. Today we are going to take a look at Form 2 Chapter 1 Mathematics, which is Patterns and Sequences. Another video regarding this topic will be coming out soon. I will be solving questions there. So without any further ado, let's start today's video. Patterns and sequences. First things first, you have to get an understanding of what are patterns. So simply put, patterns are anything that repeats itself or has a continuous arrangement. For example, a continuous arrangement that makes sense. That's the most important thing. So as I said, anything that repeats itself or in a specific order. Specific order. Alright. So for example, 2, 4, 6, 8, and so on. So from this, you can immediately see that the pattern here is plus 2. Can you see that? 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. You can see there is a repetition of numbers, which is 2. So we add 2 to the previous number, which is 2, we get 4. We add 2 to 4, we get 6. We add 2 to 6, we get 8. And for the next number, you have to add 2, which you will get, yes, correct, we will get 10. And the list goes on and on. So that is the concept of pattern. So it has to be a repetition of numbers, adding, subtracting, multiplying, dividing, or whatsoever. And also, if not that, it has to be in a certain order, in a specific arrangement. We will see examples as we go along. So for now, bear with me. The next question is, determine the patterns of the following. We have 4 examples here, and I'm going to let you try few of them after I've shown the examples. So the first pattern, 2, 4, 6, 8. It's quite the same as what I showed earlier. So let's see whether you remember or not. So what is the pattern here? Is it plus, minus, times, or divide? I will let you think. Yes, you're correct. It is plus. So it is plus 2. How do we know that it's confirmed a pattern? Because it has to repeat itself. So 2 to become 4, it has to plus 2. From 4 to 6, we have to plus 2. From 6 to 8, we have to plus 2. Since it's the same increment, which is by 2, it is safe to assume that this is a pattern, and we can confirm that the pattern is plus 2. So now, for the second one, 5, -2, -9, and -16. It might seem a little bit tricky, but I will let you give it a try. You can pause the video now. 3, 2, 1. Right. So here, when the pattern is not so obvious, what we can do is we can have a checklist, which is times, divide in the first group, or this is divide by the way, divide, or the second step will be plus or minus. So the first group is times and divide, and then the second group is plus and minus. What we're doing here is we're going to eliminate based on what we see. So for the first one, 5, -2, -9, and -16. So the first group is times and divide. Do you see any possible way, any obvious way for 5 to become -2? So when we see obvious ways, there is not any. So it's safe to assume that it's not going to be times or divide. So we're going to see plus and minus. For plus and minus, we have a safe trick. It's a neat trick we can use. So we're going to take the second number from the list, which is -2, and we're going to subtract it by the first digit, which is 5. And here we get -7. So for those who are wondering how the negative numbers work, I have another video in my channel. You can take a look at it, where I have gone in depth about how the negative numbers work when it comes to adding, subtracting, multiplying, and dividing. So here we get negative 7. So it is minus 7. That's it. It's as clear as that. So 5 minus 7. If you use calculator, you can see 5 minus 7 is indeed negative 2. The negative 2 minus 7, we get negative 9. Negative 9 minus 7, we get negative 16. That's it. So the pattern here would be minus 7. Okay, now the next question we have 4, negative 8, 16, and negative 32. So as I said, the first group is times or divide. See whether it looks like times or divide. There are few indicators. If it is times or divide, you can see that the increment of the number is exponential. It's like very, very big gaps. For example, 4 to 8 is small gap, but 8 to 16 is a big gap. 16 to 32 is a bigger gap. So it's safe to assume that it can be times. So let's see, 4 to negative 8, what can we do? We can times by 2. Is that correct? Is it just 2? Here you have to be careful. Since we have a negative symbol there, it has to be times negative 2. 4 to negative 8, we times negative 2. Then negative 8 to 16, we are going to do the same thing, times negative 2. And it's correct, times negative 2. Then from 16 to negative 32, we are also going to times by negative 2. As you can see, that is the pattern. So the pattern for this sequence will be times negative 2. As simple as that. Never overthink when you're doing sequences and patterns. It's always the simplest solution there is. Don't overthink. So now, number 4. For this, I'm going to let you try. I'm only going to give you the answer for this. Okay, so I'm going to give you 5 seconds. You can pause the video and take your own time. Right? 5, 4, 3, 2, 1. The answer for this is divided by 6. I will not be showing the answer, but if you have any questions regarding this particular question, be sure to leave it in the comment section below and I will do my best to answer it as fast as I can. Okay, so now that you have a basic understanding of what a pattern is, which is something that repeats itself, let's go to the next part of the chapter, which is interesting concepts. So using the concept of patterns, we have 2 interesting concepts that we will learn in this chapter. The first is the Pascal's triangle. So you may ask, why is it called Pascal's triangle? It is not much of a big deal if you think about it. The guy who found it was named Pascal. And then it's in the shape of a triangle. Therefore, it's called Pascal's triangle. So how this works is quite simple. We're going to start with the number 1. And we can start with any number we want. But in most cases it will be 1. Because why? 1 is the first number with value. So we're going to write 1 here. So for the concept of Pascal, it's going to be the same number throughout the entire, all the sides. It's going to be the same, exact same number. 1, 1, 1, 1, 1, 1, 1, 1, 1. I want to stop right there. So the interesting part starts right about here. So what happens there is, we're going to add 1 and 1 together to get 2, and we're going to write it right here, 2. You see, it's the sum of 1. 1 plus 1 is 2. Then here we're going to do 1 plus 2, we get, yes, 3. Then 1 plus, forgive my 3. Pardon me again. Okay, 3. Then 1 plus 1, you're going to get 3. As you see that, it's 3, 3, 3. And then for the next one, we're going to do, as you can see, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. and it goes on and on. That is the concept of Pascal's triangle. Even if the numbers differ, because in some questions they can give you different numbers and ask you to find what's the number afterwards. So for those kind of situations, it's wise to see how they have done it, because it's not that every question must follow Pascal's triangle's exact rules. Some may differ by a bit, but at the core of it, at the most basic stage, what we have to do is plus. So the bottom number will be the sum of the top two numbers. Do you see that? Alright, that's the concept of Pascal's triangle. It's going to be as simple as that. Nothing to overthink about. So after the Pascal's triangle, we have the next one is Fibonacci numbers. Fibonacci numbers is personally my favorite, because Fibonacci numbers has a history to it, in which it was discovered by a guy. Obviously his name was Fibonacci, and Fibonacci managed to find this sequence, and this sequence can be found in nature, and it's also related to a concept in mathematics known as the golden ratio, a ratio that can be found in most parts of nature, from spirals, from the patterns on a sunflower, and the list goes on and on and on. So if you're interested to learn more about Fibonacci numbers, feel free to check Google or YouTube for a detailed explanation and a graphical explanation on it. I will guarantee you it is one of the most mesmerizing and interesting things I have ever encountered in my life. It's just great. So for Fibonacci numbers, the idea is quite simple, but for the sake of continuity, let's try to do this with the same idea, the same concept I taught you, which is times, divide, and then plus minus. So as I told you earlier, for any sequence we're going to do in two groups. First is times, divide. The second group will be plus minus. Alright, so for times and divide, if you see, from 1 to 1 we are going to times by 1. From 1 to 2 we are going to times by 2. Then from 2 to 3 we can see that the pattern is does not exist anymore. There is no point there. So we can eliminate times and divide altogether. And then we're going to see plus and minus. So for plus and minus, we are going to see from 1 to 1 we are going to add by 0. From 1 to 2 we are going to add by 1. Then from 2 to 3 we are going to add by 1 again. And then from 3 to 5 we are going to add by 2, sorry. And then by 2, from 5 to 8 we are going to add by 3. From 8 to 13 we are going to add by 5. As you see, it starts to not make sense anymore. So you may ask me, then Rishi, what is the pattern here? Now this is where this pattern is quite different. What we are doing is we are adding the number to its previous number to get the next number. So let's begin with 1. So to get the next number, okay, we're going to start with, pardon me, we're going to start with 1 and 1. So 1 plus 1 we get, together the sum of this we get 2. Then for the next digit we're going to take 1 and 2, we are going to take this and bring it here, which is 1 plus 2 is 3. Then for the next number we are going to add 2 and 3, which we will get 5. Then 5 plus 3 we get 8, 5 plus 8 we get 13, 8 plus 13 we get 21. And what's the next number? I'll give you some time. What's the next number? Take your time. You can pause the video if you want to use a calculator, no problem. Okay, now that I assume that you have found the answer. The answer is 34. So how did we get 34? We are going to take 21, add it together with the previous number, which is 13. 21 plus 13 we get 34. And that's it. Fibonacci numbers, that's the whole concept of it. Add the number to its previous number to get the next number. Now that we have covered patterns, now it's time to move on to sequence. So patterns and sequences are very related. So whatever I showed you earlier as an example for pattern are the same thing as sequence. So sequence is any order of numbers that has a pattern on it. So for example, what I showed you earlier, 2, 4, 6, 8, and so on. So as we know, the pattern is +2. Since this is the number order, which is 2, 4, 6, 8, and we have a pattern which is +2, this qualifies as a sequence. So this, as a brief explanation, it's going to be order of numbers with a pattern. We have three ways to describe a sequence. The first method is through numbers, and this is what we have been doing so far. So for example, 2, 4, 6, 8. If you want to express this sequence in a number form, you're going to say just that, +2. That's it. As easy as that. That's it, +2. The second way is through words. We can express the number sequence through words. So for this, we have to memorize two sentences. Not memorize as in you have to hardcore memorize, it's more like remembering. So what you're going to do here is add or subtract a number to or from, depending whether you choose add or subtract, to from the previous number. This is going to be for plus and minus. And minus. If it is times or divide, you're going to say multiply or divide the previous number by a number. This is for times and divide. So for both of these sentences, a number is where the pattern will be written. So since what we have from the above statement is 2, 4, 6, 8, and so on, we know that the pattern is +2. With that in mind, we have to choose the first sentence, which is add or subtract. So since we know it is addition, it is add a number. So in this case, it's 2. So add 2 to the previous number. So that's how you describe in words. If it is in the opposite way, which is 8, 6, 4, and 2, which is in decrement, which is minus, we're going to say subtract 2 from the previous number. So if it is multiply or divide, we're going to follow the same suit. Multiply, for example, multiply the previous number by 2 or divide the previous number by 2. So this is how you are going to use words to express a sequence. And now let's move on to the third method. Third method is a bit tricky to understand at first, but once you understand it, it's going to be easy. So for algebraic expression, we have to categorize plus and minus aside, and as well as times and divide aside. So what we're going to do now is I'm going to give you an example, and from that I'm pretty sure you can understand it. So the example is 2, 4, 6, 8. For the sake of continuity and for the sake of understanding, I'm going to use the same exact sequence so that you get a good grasp over how it actually works. 2, 4, 6, 8, we're going to plus 2. So we know the pattern. So how we're going to use the pattern in terms of expressing it in algebraic form. So here we're going to write the first digit, which is 2 in this case. First digit of the sequence is 2. Then we're going to write down the pattern, which is plus 2. So we're going to do plus 2, and we're going to put a bracket right about here, and then we're going to write the first digit again. So this is what we are going to write: the first digit, and then the pattern. Then we're going to put a bracket, and then equals to the first digit. So I'm going to ask you, 2 plus 2 times what equals to 2? As we know, it's going to be 0. And then I'm going to write the second line. Again, first digit, 2 plus 2, and a bracket. And here I'm going to write 4 instead of 2, because we are going through the list. After 2 is 4. So I'm asking you, 2 plus 2 times what is equivalent to 4? Yes, you're correct. It's 1. 2 plus 2 times 1, we get 4. And then we're going to follow the same suit. 2 plus 2, bracket, and the next number is 6. 2 plus 2 times 2 is equivalent to 6, which is 2 plus 4 is 6. So from this, can you see the pattern? The pattern is 2 plus 2, and since this number is ever changing for every single line, we can write down as n. We always use n for this type of expression of a sequence, because n stands for number of term. So never mind, we will go into that later, but for now just remember that you have to use the letter n. Then 2 plus 2n, that's it. And we're going to write a comma here, and we're going to state the values of n. When is this expression true? So this expression is true when n is, the first number here is 0, second one is 1, third one is 2, and then since it's going to go on forever, we're going to write comma dot dot dot. This shows infinity is going to go on forever. So it's the same concept for minus or plus. We're going to use this method of writing so that you can get an understanding and get the answer. If you can't get it the first round, don't worry, rewatch this part of the video so that you can understand it. If you're still struggling, I would suggest you to write down together with me. When you rewind and watch this, write down together with me so that you get an idea of how it works. No worries, we have few more examples. So if you would like to try, please go ahead. So we are finished with plus and minus. Moving on to times and divide. Times and divide is a whole new game. But don't worry, it's still going to be easy. So I'm going to give you a sequence here which uses times as a method. Sorry, it's not times and minus, it's times and divide. So the sequence that I'm going to give you is 1, 2, 4, 8, 16, and so on. I think that you already know what the pattern is. The pattern is, yes, absolutely, you're right. It is times by 2, times by 2, times by 2, and times by 2. So the pattern is very obvious here. It is times by 2. So we're going to follow the same concept. We're going to write the first digit, which is 1, multiplied. Now here, since we have the pattern plus and minus, for the first one we wrote plus or minus, but here we're going to use times 2 as the pattern. So it is times 2. Now instead of putting a bracket, we're going to write 0 at the top of it. So I'm pretty sure you know why. Now you know why we're going to use 0 at the top, because 1 times 0 is equivalent to 0. See, I got you there. 1 times 2 to the power of 0 is 1. That's how we get the first number of the sequence. For the second one, we're going to do 1 times 2 to the power of 1. What do we get? 1 times 2 is 2. Then we're going to do here 1 times 2 equals to 4. Okay, so in this situation, 2 to the power of what will get you 4? Yes, you're correct. 2 to the power of 2, we will get 4. As you can see, the pattern is starting to make sense. It is increasing by 1, 0, 1, 2. Next will be 3, 4, 5, and so on. And since the terms are corresponding to it, like 1 is 1, 2 is 2, 4 is 4, so it's safe to assume that we can write down this formula, this expression, sorry. 1 times 2 to the power of n. Remember, I told you that it should be n, where n is equivalent to 0, 1, 2, and so on. But since 1 times 2n and 2n is the same, it is better to write 2n is equivalent. It's true. 2n is true. 2 to the power of n is true when n is equivalent to 0, 1, 2, and so on. So that's the answer. For this particular sequence, the answer is 2 to the power of 2 to the power of n when n is equal to 1, 2, 0, 1, 2, and so on. The same concept for divide. Remember, this pattern is very important. So when it is plus and when it's minus, we're just going to write plus and minus, and we are going to put a bracket beside it. If it is divide or multiply, we're going to write the same thing, multiply 2, divide 2, but instead of the bracket, we're going to put a power, not a bracket, not a multiplication. We're going to put power for times and divide. No worries, as we go on, you will start to understand. So now we have an important question to answer. What is Tn? I know that we have not gone to this, we have not said this yet. So Tn essentially means nth term. Nth term. I think it will be much easier if I give you an example. So let's take one of the sequence I gave earlier, which is 2, 4, 6, 8. So Tn stands for nth term. So example, first term. First term we will write it as T1. So it is safe to say that for this particular sequence, the number 2 is the first term, which means T1. And then 4 is the second term, which is T2. Then 6 is the third term, which is T3. And then 8 is the fourth term, which is T4. And then at one point we'll get n, which is an unknown number, so we're going to write Tn. So Tn is nth term. That's the definition of Tn. Alright, that's just a brief introduction for what is Tn. No worries, as we go along you will start to see why this is so important. There's something you will learn known as progression. We have two types of progression, geometric progression and arithmetic progression. For that topic, this is the basis. So make sure you understand it completely. If you can't understand or have any questions you need clarification, feel free to send me an email. I will have my email address in the description box below, or you can also ask in the comment section below, and I will be very happy to answer your questions. Alright, now example questions. We have this 1, 9, 17, 25, 33. So here I would advise you to try it yourself by pausing the video before I give out the answers, so that you get an understanding of how it works. First do, and then you can check with my answers later on. So you can pause the video now. 3, 2, 1. Okay, and time. So here we have a sequence 1, 9, 17, 25, 33. So as we can see, the gap is not that big. So we can rule out times and divide immediately. And then since it is increasing, we can assume that it is plus, because I have not seen any minus sequence that goes up. So from 1 to 9, it is plus 8. It is plus 8. From 9 to 17, what a coincidence, it's also plus 8. And then 17, 25, it is also plus 8. Then 25, 33 is also plus 8. So it is obvious that the pattern here is plus 8. So when we describe it in numbers, just that, it is plus 8. So now if you want to describe the sequence in words, remember this line I taught you? So since it is plus, we're going to say add how much? 8. To or from? It's 2, because it's addition. We say to what? To the previous number. Yeah, you got it. That's all. It's correct. Add 8 to the previous number. Now, the tricky part, not so tricky if you have done enough practice. Algebraic expression. Algebraic expression. What we're going to do here is write the sequence one more time. 1, 9, 17, 25, and 33. And here, we know that the pattern is plus 8. So, let's take the first digit of the sequence, which is 1. Then we have the pattern, which is plus 8. And since it is a plus minus, not times divide, we are going to put a bracket. Equals to 1, the first digit of the sequence. Then we have 1 plus 8 times something is equivalent to 1. So from experience, we know that it is going to be 0, because 8 times 0 is 0, 1 plus 0 is 1. So for the second line, we're going to write 1 plus 8 times something equals to 9. So from experience, we know that it's going to be 1 as well. Not 1 as well, it's going to be 1. So 0, 1, we get 1 plus 8 times 1, we get 9. And then the third line will be 1 plus 8 times something equals to 17. So here, 1 times what? 1 plus 8 times what gives you 17? Yes, you're correct. 8 times 2 is 16, plus 1 is 17. So we can see the pattern here already. So we are going to write 1 plus 8. Since the number is changing, 0, 1, 2. Since it's changing, we write it down as n. So 1 plus 8n, where n is equivalent to, let's see the sequence, we have 0, 1, and 2. 0, 1, and 2, and so on. That's it. That's all. I hope you got it right, but if you did not, don't worry, rest assured, we still have a few more to go. And also practice by yourself. There are a lot of questions in the textbook for you to try. So now, the next one, number 2. We have 2, 10, 18, 26. For this, I will not be going through all the steps. I will just give you the answers. Try to do it yourself. Alright? So we have, so by number, it's just plus 8. This is the number form. For the word form, I'm just going to give you the keywords. This is definitely add, and the pattern is 8. That's it. Add 8 to the previous number. Then for the algebraic expression, I'll also just give you the answer. Try to figure it out yourself. Alright? So it will be 2 plus 8n, where n is 0, 1, 2, and so on. Alright? Take a look at it and try to get your answer. Try to do the working step. This is a training. Alright? You can pause the video whenever you want. Alright, I will be going on to the next one. Number 3. This sequence will be quite similar to what we saw earlier, and I'm going to use this as an example. Same thing, take your time to describe it in 3 forms, both in numbers, words, and also algebraic expression. Pause the video, and now I'll give you the answers. So here we are going to do times by 2. That is the form in numbers, times by 2. And then in words, I'll just give you the keywords, which is multiply, the previous number by 2. That's it. And for the algebraic expression, we have the sequence. We're going to write down remember all the lines, like first digit times the pattern, which is times 2, 1 times 2 to the power of 0, 1, 2, 3, and so on, equals to the terms in the sequence. Correct? So the final answer you will get will be 2 to the power of n is true when n is equal to 0, 1, 2, and so on. Hope you got all the answers correct. If not, don't worry, try again. If you have any questions regarding this topic, make sure to send me an email, or you can write your questions in the comments section below. I will try my best to respond to it as quick as I can. That's all for this topic. Another video regarding how to solve problems regarding this topic will be posted soon, so stay tuned. And also expect some other videos related to mental mathematics tricks also. So buckle up, it's going to be a fantastic ride. Alright then, till the next video, signing off, it's Rishi, bye bye.